Continuing our videos about the top 6 most common topics on the Algebra 2 Regents, the fourth topic I want to talk to you about is sequences and series. There is almost always a question about sequences and series, and it's important to know the difference between what an arithmetic sequence is versus a geometric sequence, which formulas are used for which types, as well as the series, which are the sums of the sequences. Now, this Regents only has 2, but I have seen them appear as both multiple choice and short answers, so it's important that we are able to reason through that. Now, on your formula sheet, as of right now, there are 3 formulas related to this topic. There is the arithmetic sequence, is what it says, and all that's written there is a sub n is equal to a1 parentheses n minus 1 times d. Next, it says geometric sequence, which has a sub n is equal to a1 times r to the n minus 1 power. And the last one related to this topic is geometric series formula, which has s sub n is equal to a1 minus a1 r of n over 1 minus r, where r is not equal to 1. Now, something to keep in mind when working with these, arithmetic sequences are the sequences that are the result of repeated addition and repeated subtraction. Geometric sequences are repeated multiplication, repeated division, and series are the sum of, and in this case, geometric series is the sum of sequences that are the result of repeated multiplication and division. Now, just as an idea of what these values mean, right? A sub n means the term value, the value of that term in the nth position, okay? Leading us with n being the position. Which space in line is this value? Now, to demonstrate both of those things together, right, we have a sub 1, which is the first term. So it's whatever number is in the first position, the very first value. Now, what's specific to arithmetic sequences is this d value, which stands for common difference. And a common difference is basically what are you repeatedly adding or subtracting to get to the next term. In geometric sequences, all the values are the same. A(n), a1, and n are all the same same things, but r is actually what we're going to call the common ratio. It's what you are repeatedly multiplying by. Now, it's important to represent all division questions as multiplying by a fraction so that you have your common ratio expressed in that way. In the series formula, S sub n stands for the sum of n terms, n number of terms. So some of the first 12 terms, some of the first 20 terms. So n again is the number of terms you're looking for. Okay, now this is a geometric series, so it is going to be based off of the common ratio. So this r in both places is still my common ratio. So I'm just going to point up here. A1, again, in both of these places, is the same A1 that we have up here. Whatever our first term is of that particular sequence is going to be plugged in there. Okay, now these are currently on the reference sheet formulas. This could always change if the curriculums change, but as of right now, June 2024, these 3 are available to you. So, question 6 says, the sum of the first 20 terms of the series, -2 plus 6, -18, minus 18, plus 54, minus ... is. Now, the first word we should see here is sum. Okay, sum means that we are looking at a series formula for the first 20 terms. Now, what is happening in this series? Well, our first term, our A1, is negative 2. Our second term that is being added to it is a positive 6. So how do we get from negative 2 to positive 6? We multiply by a negative 3. So let's see if that holds up. To get from positive 6 to negative 18, do we multiply by a negative 3? We absolutely do. To get from negative 18 to 54, do we multiply by negative 3? Absolutely. So what I am noticing here is that my common ratio is a negative 3. And with sequences in series, you are allowed a base that is negative. That's different from exponential functions, so keep that in mind. And so this would be considered geometric. Okay, now there's two ways to find this sum. The first way is using the formula from down here. Okay, S sub n is equal to A1 minus A1 r to the nth power all over 1 minus r. So what are we doing? We're plugging in values. So the sum of the first 20 terms is equal to my A1 value, which in this case is negative 2, minus negative 2 times negative 3, my common ratio, raised to the 20th power all over 1 minus a negative 3. Now you'll notice since both of these are negative values, I am using parentheses to make sure I don't mess up those negatives. Okay, so putting in negative 2 minus parentheses negative 2 parentheses negative 3 to the 20th power, all in my numerator, and my denominator is 1 minus parentheses negative 3. So the value that I get here is 17433922200, which is, if we count off threes, what is that? 1,743,392,200 values. Okay. Now that is one way to do this. Remember, you can always use summations as well to find the sum of any series. Now a summation, remember, is relating to this notation. So n equals 1 to whatever value that we're looking for. And so if we have our explicit formula, we would plug in our explicit formula into the summation so that way we can calculate with our calculators again. So this is exponential, aka geometric. So A1 times r to the n minus 1 power is our explicit formula. So all I need to do is make sure I plug in all the correct values. So in my calculator, I usually put an x here at the bottom, and we are starting from our first term, and we are asking the calculator to sum up all of the first 20 terms. So from term 1 to term 20. That's what the sigma looks like. It's a summation. Now, here I would input a formula. So A1 is still a negative 2. R is still negative 3, but I'm raising just the negative 3 to the n minus 1 power. Now, if you go into your calculator and press alpha window, option number 2 says summation with the sigma symbol. We're going to choose that, and we're going to put x in the bottom. Directly next to it, we're going to put 1. On top of the sigma, we're going to put a 20. And then in that parentheses, I'm going to add another parentheses for negative 2, close it. Another parentheses for negative 3, close it. Raise that to the x minus 1. That should be an x if I'm using, we need to stay consistent. And make sure the parentheses ending the summation falls after that exponent. Okay? And if you've typed it incorrectly, you should get the exact same value, which is option number 3. Okay? So both of these require the use of a calculator unless you know the powers of 20, a power of negative 3 all the way up to 20, which I doubt we do. So please make sure that you are very comfortable inputting fractions, summations, etc. Okay, now 21 talks about the other type of formulas for sequences, which is a recursive formula. Now this is not in the reference table, so you kind of have to know about this on your own. But basically a recursive formula is what I like to call the building block formula. you have to start with a first term and you have to state that first term. And then to get to our next term, we create a rule that is based off of the n minus 1. So whether you're multiplying that, adding that, subtracting that, multiplying and adding, that's the idea behind this. So this question says a tree farm initially has 150 trees. Each year, 20% of the trees are cut down and 80 seedlings are planted. Which recursive formula models the number of trees a sub n after n years? So right away, because of the word recursive, there are two answer choices we can eliminate, 3 and 4. If you do not define your first value, you are not a recursive formula. So 1 and 2 are going to be the only choices for this. Now, they're pretty similar except the fact that we are going to be multiplying the previous term, a sub n minus 1, by either 0.2, which is 20%, or by 0.8, which is 80%. Now, if 20% of the trees are cut down, you need to think about this. How many trees are left? Well, 100% minus 20% is 80% of the trees remain. So if I'm making an equation for how many trees are still left, I'm using the 80%, not the 20%. So if I take my previous term, the term before it, multiply it by 0.8, I am left with how many trees are left. And then I add an additional 80 because the seedlings are being planted. So if I wanted to find out how many I had next year, I would take 150, multiply it by 0.8, and add 80 to it. Okay, and so those are what we call recursive. Again, this Regents only had 2 questions on sequences and series, but I have seen them in both short answers and multiple choice questions. So make sure you are prepared and know where to find your formulas from.